you're at the table portion of your worksheet. And it's time now to do these simulations so that you can get these measurements. Um, I'm just showing you two different ways that you can calculate velocity when it comes to a wave. So there's two different methods, method one and method two. They should get us the same answer. Now, we're going to use the simulation. So the numbers will vary a little bit because there's some measurement error involved in everything we do. But generally, you'll get the same velocity measurement no matter if you use method one or method two. So let's go to our simulator. And I'll show you how to do the first calculation. You do want to set this down to none, dampening to none. You need a ruler. You also want to add the timer. I know we didn't use that before. You can drag the timer around. My recommendation is to place it right here. You want to put it on slow. It'll make your life easier. You want it to oscillate. Let's just pause it for now. And the first one is 1 hertz. So let me set this thing down to 1 hertz. Okay, perfect. Now I need to take a measurement using this timer. I need to find out how long it takes for a wave to travel from this green dot here all the way down to this green dot here. How long does it take for it to travel from this spot to this spot? Um, can I move this? No, I can't. Okay. So I'm gonna hit reset, and then I'm gonna hit play. Once I hit play, a wave will be started. So I'll show you what it looks like. Here goes our wave. It's starting, and now it's gotten to the end. So I'll show you again. You hit play, the wave is starting, and now it's at the end. So the idea is we want to time how long that takes to happen. So I hit restart again. So play, play, stop. That's how long it took for it to do one wave. So let's insert that data, 1.10 seconds. Time, 1.10 seconds. Perfect. Now let's go back to our ruler and look at the distance it traveled. So it started here at the 0 centimeter mark, and it went all the way down to this dot here, 7.2, 7.4, 7.6. So that's 7.6 centimeters. I want to change 7.6 centimeters to meters. Point 0.076. Okay. Now I can substitute into this equation, d divided by t. So let's do that. And I end up with a velocity that's pretty small, but seems okay. 0.069. So meters per second. So that's my velocity, 0.069 meters per second. That was method two. Now let's check out method one. For method one, I have to measure the wavelength. So let's go back and let me maybe make this normal motion so it could oscillate regularly. And I just need to pause it at some point. It doesn't matter where. So maybe right now. Okay. So, ooh, is this a good spot? I don't know. Let's try it again. Nope. No, I don't love it. Maybe that's okay. So I paused it, and my wavelength, in this case, I'm going to go from trough to trough. So that's the lowest point on my wave. So this is a trough, and it looks like I have another trough right about here. Let's make sure. Let me use a reference line. Yeah, so for about here. So that looks like my wavelength starting at 0 all the way to this point is 6 centimeters. Okay. I want to copy and paste this into my table so I can show that I did it. So I take a snippet, paste in the snippet, and I said I got 6 centimeters. Again, I have to change that to meters. 0.06. Now I'm ready to substitute into this equation. My frequency is 1 times my wavelength is 0.06. I end up with a velocity of 0.06 meters per second. So two different ways, you get the same velocity measurement. Again, keep in mind, we're measuring. So there's always going to be a little bit of variance anytime we do a measurement. But this is pretty close. Both of these ways will get you to your velocity of the wave, how fast the wave is traveling.